So thank you all for coming. I'm going to be talking about the fate of this added nitrogen. So we've had a couple talks now about the importance of intensifying these maize systems and that inputs are really important. And I'm going to be speaking about where that nitrogen goes, so some of the environmental impacts in Africa, and then Chris Neal after this will be talking about some of those environmental impacts in Brazil. So sort of understanding the fate of nitrogen that's being added to these systems. And so really quick background, for those of you, this slide may be very familiar, but while many other countries have seen increases in yields over the past many decades, yields in sub-Saharan Africa have remained relatively stagnant. So where we have food security and malnutrition issues in many countries, that can be chalked up to food distribution problems, but in sub-Saharan Africa we still have food shortage issues in about 30 of the countries in sub-Saharan Africa. And as Pedro spoke about yesterday, in 2004, Kofi Annan, the UN Secretary General at the time, called for this uniquely African green revolution. It sort of had many prongs, but two of them, these two legs, as Pedro talked about, were improved seed and increased mineral fertilizer application. And so the rates are quite low, somewhere around 7 to 8 kilograms of nitrogen per hectare across sub-Saharan Africa, and the promotion of fertilizer applications up to about 50 kilograms of nitrogen per hectare. This figure on the right, this picture is what 1 ton maize looks like, and this picture on the right is what 6 tons of maize per hectare looks like. So you can see that there's clearly an increase in yield when you add these mineral fertilizers, but there may be some environmental consequences, and this question was brought up in an earlier presentation. And so what we're trying to do in this talk and in Chris's talk as well is trying to understand where that nitrogen may go as these agricultural systems intensify. So it's really important to make sure that we continue to balance both the food and environmental objectives so that we're not just increasing yields at the expense of the environment. So that's what we're trying to do, and we have these we have maps of our soils across Africa. We know that soils are going to be a major driver of where we can intensify, and Cheryl showed some of these maize suitability maps just a moment ago. This is a very rough cut map that basically shows the number of studies that have conducted field research on where nitrogen goes. And I usually like to say that there are more studies done on one field in Davis, California than across the continent of Africa on where nitrogen is going in these systems. It's a very understudied region, and also you'll notice, so these red dots are where we've measured gas leaching or where studies have measured, or pardon me, gas fluxes, nitrous oxide, and then these little, very hard to see blue dots are where there's been studies on nitrogen leaching, and there are very few. And you'll also notice that there's usually only one dot. So we're either just measuring gas fluxes or we might just be measuring leaching. And what we're trying to do in our studies here in Kenya and Tanzania is measure all the pathways, many of the different pathways for loss, to try to figure out the fate of nitrogen in these systems. So again, we're focusing, this is a case study on Kenya and Tanzania. These are the average maize yields. So 1.6 tons per hectare in Kenya, 1.3 tons per hectare. That's about 23 bushels per acre. You compare that to what we get across the U.S., what we get in Maryland. I don't know if you guys are doing better over here in Illinois than we are, but we've had some pretty good years. We're getting about 170 bushels per acre over here in Maryland and across the U.S. That is not the case in sub-Saharan Africa. We're about 10-fold lower, if not more, in these systems. And so clearly, sub-Saharan Africa is a vast region. Cheryl showed that lovely map of all the different farming systems, all these different agroecological zones. We're going to focus on these two regions that basically represent to us the end members of the soil texture spectrum. So if you're a soil scientist, the first thing you notice is, ooh, these soils are nice and red. They must be high in clay. And oh, those soils are nice and pale yellow or white. They're probably high in sand. So soil texture is the particle size composition of the soil. It's a very important driver of both yields and losses. So this is why we looked at these two different regions. They have very different textures, and they also have very different seasonality. So in Kenya, you can get 2 seasons per year. You have a rainy season, this long rains as we call it, that happens now, basically, April through June, and then you have a second rainy season that's October, November. In Tanzania, you have one shot. It's very variable, and that's the main cropping season. So we broke ground in Kenya in 2011, and in Tanzania in 2012. We installed these tension lysimeters or porous cup lysimeters that can measure the solution, the soil solution concentration of nitrogen. You can collect the water using a vacuum. We also use these chambers, these open-top chambers. This is my colleague Jonathan Hickman, who measured nitrous and nitric oxide, so greenhouse gases. And so what we did is had this sort of range of fertilizer applications. So just a reminder that this 50 is what is recommended by AGRA, and then we have all these increased rates all the way up to what we see more in our in our intensified systems, up to 200 kilograms of nitrogen per hectare. In Tanzania, you can kind of see in the background here, we have this, these leaves. So this goes back to the previous talk on agroforestry. One particular way that you can incorporate trees on farms is not necessarily just to have them on the farm, but to harvest some of those leaves and incorporate them into the soil. So this is kind of a cut and carry method, which is what we did. So we had this native stand of nitrogen-fixing legumes right by the study site. We had enough space, so we added an organic treatment at 75 kilograms of nitrogen per hectare, and that's what that looks like right there. So this is just to show you, the lighting here is actually pretty good. So this is what an unfertilized maize plot looks like in Kenya, right next to our high fertilizer. You can see that it's shorter in stature, and it has a slightly different color. You can see that that high fertilizer plot is a little bit darker green. So we wanted, of course, to measure that. So we let the corn dry down in the field, and we measured our yields. And so now what I'm going to show you are the data from these studies. So we're tracking, once again, the fate of nitrogen, and I'm going to show where it ends up in the maize, in the soil, and then how it's being lost. Eventually, again, trying to get at this question of can we maximize yields while minimizing environmental costs, and maybe where we can do that. What are these places that we should probably focus on and target, as Cheryl was mentioning, for intensification? So first I'm going to show you the yield data. Okay, pretty high yields. This is the first thing that you're going to notice. So that dashed red line are the average maize yields in Kenya, and you'll notice that almost every single year we're above that. Now, partly this is because we're researchers. We have unlimited access to resources, but even our unfertilized maize plots did quite well. And I want to reiterate something that Pedro said yesterday, which is management is so important. So just planting at the right time, making sure you have the right spacing, weeding at the right time can make a huge difference for these yields. And so you'll see that we have, these are the different fertilizer treatments, and these are all of our years of data. And you can see there's a lot of variability that has to do with the rainfall patterns. But in general, the yields are high, which means that the nitrogen is probably and is going into these crops. The nitrogen that we're adding is going into the maize crops. This is not the case in Tanzania. Same fertilizer rates, same people planting the crops, and very low yields. So we're basically right around that same mean maize yield in Tanzania, which means that this nitrogen that's being added is not going into the crop. It's going somewhere else. So one of the things that we do as agronomists, you can do these uptake efficiencies, which is essentially just how much of the nitrogen that I added to the field is going into that maize crop, and you just back out how much nitrogen was in your unfertilized crop. So these are the data across all of our study years in Kenya, and you'll see that we have pretty high efficiency, around 50%. It could be higher, of course, especially at those lower rates. Our uptake efficiency in Tanzania is much lower, around 25% or even lower in some years. So we need to figure out a way to increase this uptake efficiency, and I'll talk about some ways we might do that in a second. So just to summarize this, in Kenya we have these high yields, and so we also have a high recovery. We did a 15N experiment as well. So this is when you label your fertilizer and then you track it through the soil and the plant. And when this year was a great year for maize. We had a really high recovery. About 70% of the nitrogen that we added in Kenya made it into that crop. And that year when we did our uptake efficiency calculations, it agreed quite well. So we have about 78% of the N is also recovered in the biomass in that particular year. Tanzania, not the case. We didn't do a fertilizer tracer experiment, which I'm glad about, because it would have been about pouring 10K worth of expensive fertilizer down the drain. We had very low uptake efficiency across those study years. Okay, so I want to show some of our input and output data. These are balances. So the green bars here, again, are telling the story that a lot of that nitrogen that's being added in Kenya is going into the crop. These blue bars are the leaching data. The non-existent, if you squint, you might see a red sliver. That's the gas loss. It's very low. But the story is that most of that nitrogen is going into the crop in Kenya, but not so much in Tanzania. In fact, in this year here, we saw almost all of the nitrogen that we added went right into the ground and was leached out of that system. So that leaves us with this question, where does it go? So the last data I'm going to show you are the data from the soil. And what's great is that the soil data agree with our balance data. So we have, these are our clay soils in Kenya. After 2 years, this is our high fertilizer plot, there's not a huge difference. These soils are able to maintain their equilibrium because a lot of the nitrogen is going into the crop in Kenya, and that agrees with what we've been seeing in our maize. In Tanzania, it's staying in the soil. So it's not going into the maize crop, but we did a pretty good job of accounting. In fact, if you do the balance, this is almost the exact same number, which never happens in ecology. But we basically have about 300 kilograms of nitrogen that's left over, and there, oops, pardon me, there it is, in those upper soil layers. It's both nitrate and it's ammonium, and it's just prime for leaching losses. It's hanging out there. If there's not a crop to take it up, it's going to be rapidly lost throughout the system. So just to summarize, my last slide. In these clay soils in Kenya, we have this very high productivity overall. The losses are primarily offset by the high biomass production in these systems, and the N is tightly cycled. So these are the kinds of soils we want to look for and we want to target for that kind of intensification. We have low losses and we really can maximize yields. The sandy soils in Tanzania where we were working have lower productivity overall. And while there's a large storage capacity in those soils, it can saturate. So at some point, you're going to start losing nitrogen from those soils, and that may be because they saturate or because we have a rain event and that nitrogen is being leached. So these systems are prone to loss, and they're primarily probably limited by either other nutrients, like phosphorus, for example, and they're also water-limited systems. So this is where the current methods that we're employing don't necessarily balance the food and environmental objectives, so we need to look for some other methods in these particular regions. But again, just to go back to what Cheryl was saying, these are the kinds of systems that we want to look for, that we should try to target for intensification in these systems, because we have low losses and we have really high yields. Thanks to everybody who helped me with this work. Many people. And so the answer is yes, if there was a second crop. And that's what we found in Kenya, was that at the end of the season, we also had a lot of nitrogen left over, but because we can plant a second crop, that nitrogen can get taken up. So some of this is limited probably by the crop yield itself is very low, so we need some other nutrients to sort of boost that yield to also reduce the nitrogen pool. But if we were able to get a second crop in after, so this is where maybe a micro-irrigation project might be very useful, because you'd be able to get in a second crop that could take up that pool of nitrogen. That's what we do cover crops. That's what cover crops do here in the U.S. It's the crop that we plant after the primary crop to take up those residual nutrients.